This video is for numbers 14 and 15 from the Chapter 11 review. The directions state, write the rectangular equation for each equation given in polar form. So we're trying to get back to x's and y's from r's and thetas. As we look at this here, again, I'm going to have you jump down below and show you just one of the other formulas that we could use to help us with this. So right now, since we're going from polars back to the rectangulars, right, we're trying to get rid of the r's and the sines and all that kind of stuff here. So we're going to take this here and let's think about our right triangle down here at the bottom, right? We've got our hypotenuse is r, our horizontal leg is x, and our vertical leg is y. So we talked about the relationship that x equaled r times the cosine of theta, and we said y was equal to r times the sine of theta before. That still holds true here. But another one that we can use to help us here is the one that you've probably been doing since middle school, right? And that is the relationship here that's built by looking at this as a right triangle, right? If we think about our Pythagorean theorem here, we can always use the fact that x squared plus y squared should equal r squared, right? Or you could think about it, the other way around too, is r squared equals x squared plus y squared. So how's that going to help us? Let's look up here above. So in number 14, we are given r equals 4 times the sine of theta. Okay, so I don't really have a way to get the r with my sine, right? The way it is right now, I can't just move, I can't divide by r, right? That's not going to work for me because then my r is in the denominator. I can't divide by sine right now because then they're not together either, right? So that doesn't work either. So let's think about, what if I wanted to try to turn my r into an r squared? If I want to make this an r squared, okay, well, I'd have to multiply my left side times an r, right? So if I take this here, just rewriting it right now, and let's say we multiply this side times an r, and then we multiply this side times an r, we now have r squared is going to equal 4 times the sine of theta times r. Now I'm going to just reorder that and do 4 times r times the sine of theta, because we got to get rid of the r's and the sines and everything here to try to turn it back into x's and y's. So if we look at our left side right now, right, r squared, I can turn that into x's and y's using my Pythagorean theorem from down here at the bottom. R squared is the same thing as x squared plus y squared. And on the other side here, if we look closely, I have 4 times r times the sine of theta. Well, r times the sine of theta is the same thing as our y value, isn't it? So we can take this one and turn this one into 4 times y. And now we've turned everything into x's and y's here, and it doesn't really give us a specific form that it wants it in. It doesn't say to isolate y or isolate x, so we'll just go ahead and leave it in that form. So x squared plus y squared is equal to 4y. That one can be a little tricky there because you're not used to seeing them looking like that, but we'll just go with that one here for now. And now let's look at number 15. So for 15, we have the equation r equals 3. And remember, r equals 3 is just a circle with a radius of 3. So we are going to be trying to turn that into the rectangular equation. Remember, our rectangular equation is like our x minus h squared. Actually, we'll just write it out there. X minus h squared plus y minus k squared is equal to r squared. Okay, so how can we end up doing this here? Well, let's think about what's the center of this circle going to be. It's going to be 0, 0, right? So if we think about substituting that in, it's like x minus 0 squared plus y minus 0 squared equals r squared. So now we've got x squared plus y squared equals r squared. And we know that r is equal to 3, so we could just put our 3 in there for our r. We have x squared plus y squared is equal to 3 squared, which is going to be x squared plus y squared equals 9. And that actually is an answer. So are there other ways to do that? Yeah, we could look at our equation here, right? And let's say if we wanted to turn this r into an r squared, we could square this side. But if we square the left side, we're going to have to square the right side. So now we've got r squared is equal to 9, and then we can think about it as, well, r squared is the same thing as x squared plus y squared. We substitute that in. And once again, we get the exact same answer. So that is the equation for that circle in rectangular form. All right, that is questions 14 and 15 from the review. If you have additional questions, please make sure you contact me.